All right, let's talk about inductive versus deductive reasoning. We talked about inductive reasoning before. The steps for inductive reasoning is we would look for a pattern, something we observed happening over and over again. We'd make a conjecture or a guess about what we thought was happening, and then we would either prove that conjecture to be true or find a counterexample that showed it to be false. So one example we used of inductive reasoning was if you saw a bird flying. Okay, so you saw a robin fly, and then you saw a duck fly, and then you saw a pigeon fly. That's a pattern. All of these birds you saw were flying. So you might make the conjecture that all birds fly. Okay, so we observed a pattern happening with birds, we made a conjecture. Then we would either prove or disprove it by finding a counterexample, and then we talked about how, well, penguins would be a counterexample because they are birds, but they do not fly. Okay, so that is how we use logic with inductive reasoning. In this lesson, we are going to introduce deductive reasoning. Deductive reasoning is a process using logic to draw conclusions from given facts, definitions, or properties. And we've had lots of those in geometry so far. We've talked about midpoints, we've talked about complementary, we've talked about supplementary, we've talked about distance. These are all things that are laws, properties, or definitions that we could use to prove things and solve problems. Okay, so the main difference between inductive reasoning and deductive reasoning is that inductive reasoning draws conclusions based on examples, on many examples that we see over and over again, while deductive reasoning uses logic to prove the conclusion. So it uses given facts, given rules, given properties, and then logically thinks through the problem to solve it, where inductive reasoning looks at examples and uses that instead.